Hi, everybody. The GCSE Maths topic we'll be looking at today are the laws of indices. To avoid any confusion, we'll only be focusing on the rules that include whole numbers, and that includes zero and negative numbers, but not fractional ones. Now, when you see the laws of indices in your book, you might find it daunting that it's a list of many rules that you have to learn. In this lesson, we're going to build those rules as logical steps so that you don't have to memorize them. Let's first start by defining what an index, more often referred to as a power, is. A to the power of b means that the base a is being raised to the power or exponent b. Let's look at a real example to see what this means. With a base of 2 and a power of 3, we say this is 2 to the power of 3. And it means 2 multiplied by itself 3 times, which gives us 8. This is not to be confused with 2 times 3. Let's swap these numbers around. What if we have a base of 3 and a power of 2? We say this is 3 to the second power, or 3 squared, and it means 3 times 3, and it equals 9. Now, often you'll be asked to simplify or evaluate powers, such as 2 to the 5. Well, 2 to the 5 is just 2 times 2 times 2 times 2 times 2, which gives us 32. What if we have a problem that combines powers? So what if we have 2 to the power of 3 times 2 squared, and we're asked to simplify these powers? Well, one way to do it would be to write 2 times 2 times 2, and then for 2 squared to write 2 times 2. How many 2's do we have now? Well, we have 5 2's. So we can say that when the bases are the same and you multiply 2 powers together, you add the exponents. 2 to the 3 times 2 to the 2 is 2 to the 5. And that's where we get our first rule, a to the m, where a is just the base and m is the power, times a to the n is a to the m plus n. What about division? Say that we have 2 to the power of 4 divided by 2 squared. Well, one way to do this would be to write 2 times 2 times 2 times 2, and then in the denominator, 2 times 2. That gives us 16 in the numerator, 4 in the denominator, and 16 divided by 4 is 4. But 4 is just the same as 2 squared. So when we divide 2 powers, we subtract their exponents. 2 to the 4 divided by 2 squared is 2 to the 4 minus 2, which gives us 2 squared, which equals 4. Let's do another example. What if we had 3 cubed divided by 3 squared? Well, we could just subtract the exponents, and that would leave us with 3 to the 1. Now, this bit is very important, because if we work these out the long way, 3 times 3 times 3 is 27, and 3 squared is 9. 27 divided by 9 equals 3. So 3 to the power of 1 and just 3 are the same. So when you have a base raised to the power of 1, the answer is just the base itself. A to the 1 equals A. 5 to the 1 equals 5. 16 to the 1 equals 16. So far, we know that A to the m times A to the n is A to the m plus n. Let's write down an example. 2 cubed times 2 squared is 2 to the 3 plus 2, which gives us 2 to the 5. A to the m divided by A to the n is A to the m minus n. 3 cubed divided by 3 squared is 3 to the 3 minus 2, which is 3 to the 1, which according to our rule, A to the 0 equals A, is just 3. So far we have 3 rules to build on. What if we take a power and raise it to another power? Well, first we have to resolve what's in the brackets because of BIDMAS. So we do 3 times 3, which is 9. And if we square that, that's 9 times 9, which is 81. But if you check 3 to the 4, 3 to the 4 is 3 times 3 times 3 times 3, which also gives us 81. So what did we do with these two powers? Now, in this example, it may look like we've added them together. We've actually multiplied them. So we have 3 to the power of 4. Let's make it clear with another example. If we have 2 to the power of 3 raised to the power of 2, that's 2 cubed times 2 cubed. And our previous rule says that when we have two powers being multiplied with the same base, we can add their powers. So 2 cubed times 2 cubed is 2 to the 6. That's 3 times 2. That gives us our fourth rule. A to the B raised to the C is A to the B times C. When you raise a power to another power, you multiply the powers. So one more example, 3 squared raised to the power of 3 would be 3 to the power of 6. What if we have more than just one term inside the brackets? What if we have AB to the power of 3? Well, that means AB times AB times AB. How many A's do we have multiplied by each other? 3. So that part is A cubed. But we also have 3 B's, which makes it B cubed. From that, we can get the rule AB to the n is AN times B to the n. Finally, we're going to explore 0 and negative numbers. And you're going to see how they're just an extension of the rules that we've learned so far. We start with 2 to the 4, which is 16, 2 cubed, which is 8, 2 squared, which is 4, 2 to the 1, which we know because A to the 0 is, or A to the 1 rather, sorry, is A. 2 to the 1 is 2. what if we were to continue using this logic? Next, we would have 2 to the 0, 2 to the negative 1, 2 to the negative 2. Going down, we're dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. So to get to the next line, we can just do 2 divided by 2, which is 1. Now, because this would work no matter what base you had, this gives us our next rule. A to the 0 is always 1. Any number raised to the power of 0 is 1. Let's see what happens when we go to 2 to the negative 1. Well, we just keep dividing by 2. 2 to the 1 is 1 over 2. 1 over 2 divided by 2 is 1 over 4. But 1 over 2 is just the same as 1 over 2 to the 1. And 4 can be rewritten as 2 squared. So 2 to the negative 2 is 1 over 2 to the positive 2. 2 to the negative 1 is 1 over 2 to the positive 1. So when we have negative powers, we take what we call the reciprocal. That's when you take your number and you do 1 over that number. So 2 to the negative 3 is 1 over 2 to the positive 3, which is 1 over 8. That gives us the rule a to the minus n is 1 over a to the positive n. And that's all the rules for whole numbers, including 0 and negative 1. I hope you enjoyed that lesson. Please join me next time for more math.